Okay, so we're picking up with, this was the last example that we did, so let's just kind of use this to talk it out a little bit. We were talking about the first and second derivative test in 4.3. It's a long section because it's a lot going on with it. Some key points to bring back to you. The first derivative test is what is happening around the critical points. The first derivative, being positive or negative, tells you what about f? Use the chart, increasing, decreasing. So if the first derivative goes positive, then negative, what does that create at the critical point? A max. If the first derivative goes negative and then positive, what does that create? A min. Okay, so that's kind of the first derivative in a nutshell. There's some stuff with endpoints as well. But let's go to the second derivative test, which is our faces here. You find the critical points, just like the first derivative test, same idea. We've got our numbers here, but then you plug them into the second derivative, and the difference with the second derivative test is what is happening at the critical points, not around it on either side, but what is happening there. The second derivative, being positive or negative, tells you what about f? Concavity, concave up and down. If the second derivative ends up being negative, the graph of f is concave down, and what does that create? A max. If the second derivative at the point is positive, it's concave up, which creates a min. Concave up and then a min. Okay? So kind of in a nutshell, what we're doing here. So we're going to go on to example 7, and because we're just trying to finish up some examples, like this has part A through D. I don't know if I'll touch on every point, maybe even just discussing. Okay. All right. So we are given f prime this time. One of the pieces of advice that I'm going to be giving you, especially in fourth quarter, but it can start now, and that is it's really important to get the mindset, like at the beginning of a problem, like free response questions on tests and quizzes, things like that. What am I given? And what am I looking at? Because often you're given a graph. So you need to kind of get yourself in that mode. So what are we given in this problem? Not the function, the first derivative. We're given the first derivative. So we need to have that in mind when we answer this question. Identify the extrema of f. But keeping in mind, we're given the first derivative. We're not given f. So how do I find, I'll go ahead and tell you because we're coming off a week of break. Critical points is what we need to find. So what are the 3 ways to find critical points? Derivative below 0, derivative does not exist, and closed interval endpoints. Very good. Well, this is not a closed interval, so we won't have that. So what do I do first for this particular problem? Find the zeros. You're setting it equal to 0 because you already have the derivative. So don't take the derivative of this and then set that equal to 0 because you already have the first derivative. All right. I would like to factor out x squared, but also divide by 4 at the same time. Can you do that and tell me what's left? X minus 3. Good. And so the zeros are what?
0 and 3.
Good. Okay. Now, I'd like to show you, remind you of a little something on this here really quickly about, and I'm about to graph f prime. And what I want to remind you of is these are the zeros of f prime, right? Like the dots on the x-axis. But what that squared does on the graph is what I want to show you. Looking at the graph of f prime, how many legs does it have? 3. And how does it finish? It finishes up, so it's going to be down, so it's going to be some kind of shape like this, yes? So applying this to the graph, I'm going to draw it and I'm going to explain why I just did what I did. It looks like that. Because the x, which is where the 0 comes from, is squared, we talk about touch and cross. Do you remember that concept? Touch and cross. Touch is for even, cross is for odd. There is an odd number of these factors, like there's a 1 right here. So that's why this one is crossing through. And because this one is even, it's a touch. So let's evaluate what is happening here if we're supposed to find extrema of f. Look at the chart if you need to. But if we are looking at the first derivative, we need to be talking about like an increasing versus decreasing change or a decreasing increasing change. So what needs to change on f prime? The table is the what? The sign. The sign needs to change for f prime for f to have a change in direction, like increasing, decreasing, or decrease, increase, right? So you need to have some kind of sign change. I wanted to pull the graph in because is there a sign change at 0? There's not, but there is at 3, right? So there is not a local max or a min at 0, but perhaps something else going on. We'll talk about that in a second. Okay. So I was just curious as to how they answered this because they actually don't give the full you can't give the full coordinate because you don't have the function. Sorry, I had to talk myself into that one. You don't have the original f, so you can't take the x values and plug them into the function to get the y value. Make sense? So when you're giving the extrema, you're just talking about, not red. You're just giving the x value at which it's occurring. Okay, now let's get a little bit more specific though. Is it a min? Local min, we'll talk about y in just a second. At where? At x equals 3. Let's talk about why it would be a min. We talked about the sign change, but what sign change is occurring? It's going from what? Negative to positive, which turns from decreasing to increasing, which does that, which is your min. Very good. Okay, so that's our answer to part A. Let's go ahead to B because I think we're going to talk more about that 0 here. This is actually, since we already have the graph, is actually a pretty easy question. Find the intervals for f increasing and also decreasing. So let's do some little notes here. For f increasing, what am I looking at on f prime? Positive. F prime positive. For decreasing, I'm looking for f prime being negative. Okay. These should be pretty quick answers because we have a graph to look at. Where is the f prime graph positive? An interval. We're talking about from this to that. From 3 to infinity. From 3 to infinity, f prime is above the x-axis. Now for decreasing, the question is, where is f prime negative? So what is the first interval? Negative infinity up to where? No, you have to break it up. 0. You have to stop it at 0 because at 0 it is neither positive nor negative. And then you pick it up and say from 0 to 3. Okay, moving right along past that one, that's a pretty simple answer. Fine. Okay. Find where f is concave up and down. Okay, I was trying this before the break. Let's see if you caught on to it. When you hear the word concavity, what do I want you to think? Second derivative. Can it be found with the first derivative? Yes, but second derivative is much easier. So we have an f prime function at the top. We can easily find the second derivative of that. Bring it back, there it is. So f double prime is equal to what? Minus 24x. Very good. Okay. Now let's start talking about the graph, but then we've got a little more algebra to do. What kind of a shape is this graph? It is a parabola facing which way? Up. Up. So, but it would be necessary to find out where is it going to cross the x-axis? Where are the zeros of this? So let's set this equal to 0. And I'm going to do the same thing where I divide by 12 and factor out the x. And when you do that, what are you left with? X minus 2. So the zeros are what? Right. And this one is just normal. There's no touch cross kind of situation. They're just both crossed. That is an upward facing parabola looking something like this. And making note that this is the graph of f double prime. Okay, what do I care about for determining f being concave up or down? Positive or negative of this. So let's make that note. Concave up, f double prime positive. Concave down, f double prime negative. Okay, so just like on part B, noting like what are we looking at? What's the translation? So we're looking for intervals again. So concave up, where will that be occurring? To 0, good. And then from 2 to infinity, good. Okay, and then how about concave down? 0 to 2, very good. Nothing weird on that one, just it's what it is. Okay, I think I'm going to skip the last one. It's sketching a possible graph of f. We could kind of put all this together and come up with a graph. It's basically putting everything you just did together, the increasing, the decreasing, the concavity, all that stuff. Really quickly, though, because I thought we would address it again, and you kind of would in the graph. Let's talk about what is going to happen at 0. Look right here at 0. What is happening on, let's put it in terms of each one. What is happening on the second derivative at 0? Change of sign. What is happening on the first derivative at 0? Change in direction. What is that going to produce? This is the dead giveaway. Inflection point. Because if you're changing concavity, that's where your inflection point comes in, right? And it's still happening when you have a change of direction on the first derivative. But okay, because I want to move on to example 8. There is yet one more in this section. It is the perpetual never-ending section. Because this one addresses something a little bit unique. I'm going to start recreating this graph, and I'll talk about what we just wrote down. And I'm going to use the graph and just kind of make notes on it. That is supposed to be a parabolic. It's not pointy. I'm just trying to make it bottom out in the right place. That is a line, and then this one's going to be a line too. And reminding you here that this is the graph of f prime. So the end goal of this example, it's not a terribly long one. It's talking about finding the extrema of f and also sketching a possible graph of f. So what's unique about this one is pointing out in the description that even though f prime is discontinuous, it says it in the description and it's also in our piecewise graph here, it's telling us that f is continuous. Okay, so a function f can have a discontinuous derivative. So let's talk about what that will do on the graph. Okay, so this time we're in the mindset of f prime again, but we're looking at a graph instead of given a function. Okay, so what do I care about f prime as it pertains to f? Positive or negative. Okay, so let's talk about the things that are happening here. So we have an endpoint. We can just start with that one here. And after the endpoint, the function is positive. Sorry, f prime is positive, not the function. F prime is positive. At endpoint -4, after that, f prime is positive. What does that mean f is doing after it's increasing? So what did we just create there? A min, because we're stopped at the endpoint and then we go up from there, so that creates a min. Okay, then what happens right here at -3? Right, it does turn to decreasing because we change sign here. So if we change sign on f prime, what did we just create? Remember, we went increasing and then decreasing. You just created a max, right? So let's make a little note of that. Let's start marking it up, so not just talk it out, but there's going to be a, here, sorry, I'm trying to figure out how to figure this out. F min at x equals -4, and that's because f prime is positive right after it. Then we're going to have f will have a, what did we just say, positive, negative. So that's going to be a max, right, at x equals -3, because we switched from positive to negative. So that means we switched from increasing to decreasing, right? Oh, the concavity, right? There is a concave situation going on right here, because what's happening at -2? A change of what? Direction, right? So let's put this up here. We're going to have an inflection point at x equals -2 because we changed from decreasing to increasing. So just kind of noting what is going on there. But then what's going on at -1? We have a change of what again? Sign. Okay, so we have, let's talk out what it's going to be. We're going to go from negative to positive. So what will that create? Negative, positive. That'll create a min. So f is going to have a min at x equals -1 because we're going to switch from negative down here below to positive. Okay, but then something is happening here at 0. What is happening on f prime here? The derivative does not exist, right? There is a discontinuity. What might that look like on f? A corner or a cusp, exactly. So we have some kind of corner or cusp situation. Let's do that here. F, corner, cusp, something at x equals 0. And it's because of the discontinuity. I'll highlight this in yellow if you can see that. Okay. Then look at what else has happened here at 0. On the left side of 0, f prime is positive. But on the right side of 0, it's now It's now negative. So if f prime has gone from positive to negative, what is also created at that corner cusp? A max is also created. Oops, throwing my pencil. So f, that just jumped out of my hands. So f is also going to have a max at x equals 0 because of that. Okay, and then we have a, I think going on here to the next 0 here, we're going to have, I'm running out of space. We are changing from negative to positive. So what is f going to have at 1? A min, negative to positive. So f min at x equals 1. Okay. And then at 2, we have another discontinuity. So what is going to be happening at 2? There is going to be that, but then also the discontinuity is going to create what? A corner or cusp. So f corner cusp at x equals 2, but also we have a change in sign because we are going from positive down here to negative. So there will also be, x equals 2. Let's see, this time we're going from positive to negative. So what does that create? That's a max. So f is going to have a max at x equals 2 as well. It's going to be a corner or a cusp, but it's still a max. And then what? And then the endpoint, yeah, because after that kind of remains constant there, remains steady. But then we have an endpoint, and it's going to be, it is going to be a min. So why is 4 going to be a min? It's going to be decreasing to the endpoint because before the 4 is negative. So we have a min at x equals 4. Woo! Yeah. So that's a lot of that going on. And again, for sake of time, I'm going to keep it moving. But that's what I wanted to show you. Like how do you interpret these things on a graph? What are you looking at? Okay. All right. That is the end of 4.3.